Good morning, everybody. Let me first introduce myself. My name is Jan Mees. I'm working at Infrabel for 27 years now. I started as a track engineer, been responsible for signal and power supply, and I'm now in charge of the entity in charge of maintenance and renewal of the whole Belgian railway network. I'm also part-time professor at the Ghent University in civil engineering. And just to make clear, I'm not an IT specialist, so I'm more part of the business, the users of these solutions. So, and I want to give you my view on how digitalization should improve our organization. Yes. Who's Infrabel? Yes. Infrabel, for those who don't know, is the infrastructure manager. So we are managing the Belgian rail network. So all Belgian trains are running on our network. So we keep our infrastructure in top condition by doing maintenance and renewals on time. And Infrabel has chosen digitalization as one of the main strategies our main strategy drivers to try to optimize our processes in our search for operational excellence. Nice sentence. And so this is not a new approach. So digitalization itself is not new, but we believe that digitalization is bringing us further into this operational excellence. Today, I want to show you some examples on how we do this in different domains, and I hope to show you also where we believe pitfalls are and where the success parameters are. Belgian railway network, it's about 6,000 kilometers long. So it's a medium size network if you compare it to the neighbors in the rest of Europe, but it's quite intensely used network. The backbone is in Brussels, so we have a lot of regional trains going to Brussels, but we also have an international high-speed network connecting to our neighbors and important freight routes from our harbors going to the rest of Europe. Now, as most infrastructure providers, we have 5 objectives which I would like to explain a bit more in detail. Safety is, of course, obvious for our customers, is obvious for our passengers on our trains, but we have to say that the safety of our track workers is not yet at the same level of technology as it is for the safety of our trains. And so we really believe that's one of the aspects on which we have to work, and I'll come back on that one later. But for customers, reliability and trains on time is in fact the most important quality parameter on which we have to work. And yeah, thanks to Corona, reliability is okay, but it's something we have to work on every day to improve. We have a dense network, so we see there is every year a need for more capacity. We have a small drop on customer demand due to Corona, but we'll believe it will come back, perhaps not completely in the same way. So perhaps there will be shifts in customer demands, but the need for capacity will increase on the next decades, that's clear. We are a public sector, so we have to manage our budgets properly, and we have to improve our operations so that we can cut the costs year by year, as every other company should do. We have a green product. We are convinced of that, but that's not enough for the future. So also on that aspect, we have to improve every year. So that means if you look at all those 5 objectives, which are very much linked to the RAMs, which Pierre was talking about also, then our stakeholders are expecting every year more and more from us. And we as a company, we believe that a lot of these expectations can be met by digitalization. So that's why we believe we have to work on this digital railway and improve on different aspects. Digital railway is not new, as I already said in my introduction. So I want to focus later on more on smarter maintenance and safety issues for track workers. But if we go back to the past, we see that digitalization has started a few decades ago. It's about 25 years ago, we started digitalization on the traffic operation. We had a lot of electric interlocking system managing locally the safety. Traffic was also locally managed by traffic operators in signaling posts. And 25 years ago, we started to build an electronic overlay on that to digitalize this process. This helped us over the last decades to reduce the number of signaling posts from several hundreds to only 10 today. And so now we can manage the whole traffic with 10 signaling posts. We could go further, but the advantage is no longer there. This is a permanent evolution. So a few years ago, we started also to automate the traffic operation. So the traffic operator doesn't have to manage on a permanent basis the traffic anymore. It just has to manage it by exception if things go wrong or not going like it's planned. On the other side, we see ETCS, where 10 years ago we said we want to implement this European train control system on the whole of our network. And this is also putting an electronic overlay on top of the train management system. So we do electronic verification on speeds, on movement authorities, and so on. And this electronic overlay, together with this electronic system, digital systems in our signal post, offers big opportunities for the further digitalization. And within the next years and decade, we will be able to run trains automatically, hopefully without drivers. But I don't want to further focus on these just as an example that digitalization is not new, and that in fact digitalization in the different domains are becoming complementary and help digitalization of the other domains which have not been developed further on. So I now really want to give some examples on how we did digitalization in maintenance. That's the Smarter M project we started also about 10 years ago. And a more recent project, Safer M, where we want to improve the safety of our track workers in the field. Smarter M, as I said, started 2011. And in those days, maintenance was performed fully locally. Local people checked their systems, determined whether they had to do some maintenance, and perform this maintenance as they thought it was necessary. When introducing the digitalization of our maintenance, we reviewed this process completely. And we said we have to introduce a PDCA cycle through the whole organization and bring these different steps in different locations into the organization. The digitalization for the different steps in the PDCA cycle are, of course, need a different approach. Digital status check is easy. You can measure. We have a lot of technologies available today to do this digital checks, but the evaluation needs further investigation and further development. Planification, there are also possibilities. The execution itself is the hard stuff, the hard work is a bit more difficult, but also there we see that we are starting to digitalize the means of doing this maintenance, permitting also to get the feedback on what we did from maintenance. An interesting example is what we did with our turnout maintenance. So turnout maintenance was performed only 5 years ago, just by manual gauges locally. You had to measure all dimensions in the turnout, and that took several hours to verify just one turnouts. And we introduced a few years ago our measuring train with laser video systems and inertial measuring units, which permit in just 1 or 2 runs to verify all these dimensions at a speed of 40 kilometers per hour. So in one run, we have all safety dimensions, and we know all defects basically that are in our turnouts. But we didn't just deliver this information to the local people so that they could go on with their job. No, we also introduced a data cell, in this case a track data cell, which has to interpret the results of this measuring run and delivers the work orders to the local people. So the local people get the information on what they have to do as corrective maintenance. So it's not only the check that has been taken over by a train, but the evaluation also has been taken over by this data cell. In order to do this, we had to re-engineer the whole data flow through our organization and the data management also. This permits not only to give all this information to all people who need it, but it also gives the opportunity to combine it with other data which are necessary in the end to have a good interpretation, a good evaluation of your asset status. So all this data flow has been introduced in our SAP system, which is running on the whole of our organization. That's basically the check. On the data evaluation. We said, okay, you can deliver the work item straight away from these results, but the opportunity of creating a data cell who deals with this data offers additional potential for improvements, because this data cell can combine this information with other information from monitoring systems that are put on to the existing turnouts, but also from data, for example, for the traffic operation system I was talking about. So we have a lot of information available from this system that has been running for 25 years on our assets. And the combination of all these information gives the possibilities to tend towards more and more predictive maintenance and to define work orders, not when the defect has occurred, but when we think it's the proper moment to do this maintenance. And so the quality of your work orders is by creating this data cell is improving. In order to do this, you need to have some data experts and to data analysts that are working on this, and there's not only track engineers who help to define this correct process, but the combination of data expert together with the technicians help to get further. That's about smarter maintenance. Now let's focus more on the safety issues we had with our workers. And the Safer M project was developed a few years ago to improve also this process and also try to see how we can, through digitalization, help improve these processes. Today, safety of workers is done in a very archaic way sometimes, and we still using some elements from signaling from about 150 years ago, like the red flag you can see on the picture, to protect our people, which is no sense, and so there is a large potential for improvements. There are different projects within this Safer M program, and I just want to highlight two of them. One is the Prodigis project, where we want to improve all procedures that help people assure their safety when they get into the track. Before I enter the track, there are a lot of issues I have to deal with to be sure that I can work in safe conditions. Of course, I have to avoid trains running on the track when I'm working on it. I have to be sure that the current is cut on the overhead lines when I get near to it. I have to make sure that trains running next to me are informed and slow down if necessary, and so on. So a lot of issues have to be dealt with, and a lot of procedures exist today to deal with that. But these procedures today are purely paperwork. So every procedure, you have a small leaflet like this, which you have to fill in during the night in order to register the communication, the safety communication you had with the different stakeholders you're working with. Sometimes up to 15 of these procedures have to be fulfilled. This means tremendous loss of time, very inefficient, and even introducing risks if some errors are made. If you have the track out of service for 4 hours and you first have to fill in during 30 or 60 minutes these paperworks, that's not very efficient. So a big potential for improvement, and digitalizing paper is in fact a very easy job, an IT specialist would say. But we avoided to do so. So before doing so, we said, let's have a look on what is now the objective of all these procedures, and not just have a look on the people in the track who has to fill in these forms and try to digitalize those. No, let's think of the whole process. What do we want to reach with all those procedures, and how can we do it in a different way to serve the needs of all stakeholders involved in these processes? I don't want to get into detail, but from this discussion resulted in 3 basic ideas instead of just purely digitalize the process. First idea, make all relevant data available to all stakeholders. Looks obvious, but if you just digitalize, it's not the case. Everybody should see the same data, of course you should say, and avoid data input. Writing on a leaflet during the night is not easy, but writing on a tablet is not easy neither. And everything is properly planned in advance. You just have to select items instead of writing down. We also developed this on SIP, together with the other developments we had, which offers opportunities again in combining information. And this is how it looked like. Just a tablet where you can choose your works, but this tablet on this sheet doesn't tell you a lot. So let's go to a little movie where, if everything goes right, you should see Pierre, who wants to do a job in the track. Pierre has properly planned everything, so that means that everybody knows that Pierre wants to do some work, and Pierre gets at site and is selecting the job he has planned.
Traffic Excuse officer. Me, Jan, before you go further, just wanted to let you know you're a couple minutes away from end of the session.
Okay, good. I'll make it a bit shorter. Traffic operator has selected the work he has to do. He is blocking the trains, and so Pierre is aware he can work on this now. Same thing for the current overline. So he has also communication with the manager of the current systems, who checks if everything is safe. And through the digital system, Pierre is informed that everything is safe. He can continue his procedure and can start really work in the track. Good. I'm going to be very short on this one. I'm going to shift directly probably to the movie. As I said, we have still flags, which are the first signaling system used in the track. These are still used to the limit, the track zone where people wants to work. but when an operator is working, is not always thinking about this area, is especially thinking about his work he has to do. And so again, let's have a look on this movie where we can see that additionally to the flag he still uses, we also put, and that's the black box here, a GPS tracker. And this GPS tracker is communicating with the people in this maintenance train. So here we see Pierre again, who wants to do some work on the catenary system. He starts to communicate, to say, I want to start working. He goes to his track site, and on the track site, he will go out of his driver seat and start working on his platform. And now his focus is on his work, but I have to be sure that he remains within his free zone. And there he gets information when he is approaching this area. So these are just simple means to improve the safety of his work. These are just small bits to assist our workers in his safety management. This is not really the same level as we have for signaling systems, where we are with interlocking system managing the safety. This is the next system we are building today, but this will take some time. And in the meantime, we try to improve the system with just small solutions, just like these. That was my presentation. That were just the examples I wanted to show. Here, just a few of the success factors I wanted to highlight, just very shortly. Always look at your process again. Look at this process with all stakeholders from end to end. Involve these users from the beginning and through the whole digitalization process. Keep it simple for the business, but try to use also simple solution. And the data expertise is giving opportunities to further improvements. That's the whole of my presentation, and I'm available if now or later on if there are any questions.
Wonderful. We'll do Q&A after all three presentations are done. So let me hand it over now to Diego.